Colby, math.com.
Okay, we learned about the Pythagorean Theorem today, and I'd like to do problem number 11 with you. Problem 11 is being given to you in advance of us formally working on the coordinate plane together, although I know you've worked on the coordinate plane in the past, so we'll draw on your experience with the coordinate plane, and then that will be a good introduction to some work we'll do with ordered pairs in the coordinate plane coming up in the next few days. When I read this question, it says a square positioned in quadrant 1, so anywhere the x and y coordinates are positive, that's quadrant 1 on the coordinate plane. That square is positioned in quadrant 1 so that two vertices lie on the axes. So this vertex of the square lies on the y-axis, and this vertex of the square lies on the x-axis, while a third vertex right here lies at the point 7, 4. So let's take a second and talk about what that means. 7, 4. Any point on the coordinate plane is an ordered pair of coordinates. It's always the x coordinate followed by the y coordinate. X comes before y in the alphabet, and x always comes before y in your ordered pair. And so the x coordinate, the horizontal coordinate for this point is 7, and the vertical coordinate is 4. We're asked to find the area of the square, which could seem impossible at first because we do not know the side length of the square. But when we start to look at some of the geometry of this picture and draw some lines, we'll start to reveal some things. So if I drop a line down here, we know that this horizontal coordinate, the x coordinate, is positive 7. And if let me just do a dotted line over here. That's not very straight. It's easy to draw a straight solid line, but I need to freehand a straight dotted line, so let me see what I can do a little better here. Not much better, but okay, so that vertical coordinate of that point is positive 4. And if I start to draw some more lines, you'll see that this square is surrounded by 4 right triangles. Here's a right triangle, here's a right triangle. And by inspection you can see that these right triangles are all congruent. They have different orientations, but they're all congruent. And the key to solving this whole problem is understanding that these congruent triangles have congruent corresponding sides. So this leg of this right triangle is congruent to this leg of this right triangle, and this longer leg of this right triangle, and this right triangle. And we also know the length of the leg of this right triangle because this leg is 4 above the x-axis. So this leg has a distance of 4 units. This leg right here, the corresponding congruent leg of this other right triangle, has a distance of 4 units up to that point. And if you start to fill in some of the dimensions that are not yet filled in, you start to get enough dimensions of each right triangle to apply the Pythagorean theorem and start to solve this problem. So that's about as much as I want to say. Hopefully you see a strategy here. There's a couple of different ways to solve this, but try that during the pause and then come back and see how you did.
Paused.
If this horizontal distance is 4 and this total horizontal distance to this point is 7, then this must be 3. And so we have all of these right triangles have legs of sides 3 and 4. We confirm that again by this is 3 plus 4, this is 7 up here. Okay, so let me just draw one of these right triangles off to the side. If the short leg is 3 and the long leg is 4, We learned in class today that the legs are A and B, and the hypotenuse, the longest side in the triangle, the side opposite the largest angle, the right angle, is called C. And we learned A squared plus B squared equals C squared. So we substitute 3 for A and 4 for B. We get 9 plus 16 equals C squared. 25 equals C squared. And then to identify C, we take the square root of C squared. That will, remember, square roots and squaring are inverse operations. So by taking the square root of something that's being squared, you undo the squaring. In the same way that if you square a square root, you undo the square root. Just inverse operations, so we get C. But I have to apply the property of equality and take the square root of both sides of that equation, and so C equals 5. And so this hypotenuse is 5, and that hypotenuse is also the side length of the square. So we have a square with side length 5. So the square's area must be 25. So the area of the square is 25. We weren't given any units, so we'll just say units squared. I hope that helped with the assignment. I'll see you tomorrow.